right, we are up to review number 7. Okay, our first problem here, we're looking at graphing a parabola. That's what a quadratic is, but we have the inequality arrow. So what we're going to do, as we normally would, we're going to go ahead, we're going to find our vertex, our negative b over 2a to get the x value. So negative 2 over 2 times a, my a value is 1, the number in front of my squared term. So my x value ends up being 1. To get y then, I just plug that negative 1 back in wherever there's an x. Got to remember it's a negative though, that's kind of important. And again, you can punch this whole thing into the calculator or you can do it in your head. So 1 minus 2 is negative 1 minus 1 is negative 2. And again, we talked about how you can do slope on one like this if there's not a coefficient, where I could go up 1 and over 1 each way, and then up 3 and over 1. But again, if you're worried you're not going to remember that, no fretting. We just go ahead. We put it in the calculator. We get our chart with our vertex in the middle, and you get the same points. Okay, so it's not a big deal. Now the thing I have to watch though when I get to these is I have to pay attention if it's a dotted or a solid line with my parabola. If there's not a line underneath, we go dotted. And then, well, how do I figure out where to shade? Oh yeah, you got to shade on these. Right, we're always going to pick a point that's somewhere inside the parabola. Now, if I can use 0, 0, I like 0, 0. And here's why. If I test 0, 0, plug in 0 for y, plug in 0 for my x's, and basically that wipes out everything except this negative 1. It makes the math easy. So then the question is, okay, 0 is less than negative 1. That is not true. That's false. So, since that's false, I don't shade where the dot is inside. I shade outside where the dot is not. And that's how we're going to deal with some of those. We've done lots already with our solutions and writing the inequality and interval notation on a couple of the other reviews. So I'm going to have you go back and look at those on that, just because we don't need to go absolutely crazy on these. But now that I think about it, yeah, let's go ahead and look at one of these. So let's look at 4. We're going to factor these. Multiplies to negative 12 and adds to negative 4. Let's see, I know it's a negative and a positive to multiply to a negative. And I know the negative's going to be the bigger number because it adds to negatives. Let's see. 12 and 1, no, it doesn't get me to 4. 4 and 3, no, it doesn't get me there either. 6 and 2. 6 and 2, okay. And if I set those each equal to 0, I just change their signs. And as I've mentioned before, and I still am, I'm a big proponent of drawing a picture on this. Because here's how this works. Any one of these graphs gets busted into 3 sections. I call them A, B, and C. When I test a point, I test a point somewhere in section B. You're like, well, why are you testing a point in section B? Because if it's true, my answer's in here. If it's false, my answer's out here. So I'm going to test out 0. 0 minus 0 minus 12 is less than 0. Is negative 12 less than 0? And that's true. So it would just be in section B, and then since I'm being asked for the interval notation, which is just left to right, I jot that down and I'm in business. Nothing too bad. Nothing too bad. When I get to 5, okay, simplify the expression. If there's a minus, I distribute that negative all the way through. So we change signs on everything in the second set of parentheses. Then we go looking for the biggest exponent because we want to write this in standard form. So 8n to the fourth, 6n squared minus 8n squared, negative 2n squared, plus 8n, and then positive 8 minus 6 is positive 2. And I'm set. So we'll take a flip over to the other side. Next up, we've got function notation over on the back. Now again, here's the key with this. Okay, when it says find f times g of x, my x is just a label. Okay, I don't need to multiply it by anything or anything like that. It's just saying take the f function, 2x plus 1, and times it by the g function, negative x minus 5. In other words, foil or make yourself a box. And multiply your way through. So we multiply to fill the box. And once the box is full, now we go and we're just combining like terms. Well, I've only got a single x squared term, so I write it down. Negative 10 minus 1 is negative 11. Don't mess with the exponents anymore. Don't mess with the variables. We're just combining like terms. Minus 5. That's it. Okay? Do not go back through and multiply by x. Don't do it. Same type of things going on in number 9 then, except now instead of x we have an actual number. So I plug in the negative 3 where the n is in my first one, so I have negative 3 minus 2, which is negative 5. And then I plug the 3 in my second one here. So I've got 4 times negative 3 plus 3. Negative 12 plus 3 is negative 9. And I just times those together. So again, we're just taking that value and plugging it in. And that's all it's going to be. Now this last one, a little more interesting. H of g of 5. Now that's not a multiplication, that's an open dot. So it means what I'm going to do is I'm going to do g of 5 first. So I'm going to take my 5, I'm going to plug it in here. So negative 3 times 5 plus 3. Negative 15 plus 3 is negative 12. Okay, so that's what g of 5 equals. So what I'm going to do with that is, I know now that g of 5 is negative 12. So that's what's in the parentheses now. So I have to do it in pieces. I kind of work my way backwards. And now h of negative 12. So everywhere in h that I see an x value, I go ahead and plug that in. And again, if you plug it in the calculator, that's fine. Make sure you use parentheses. We have 144 minus 36. Yes. No. No, Harty. Not even close. It's what I get when I try to do all these things in my head all the time. It's 108. It really is. That's why it pays to use the calculator. And then finally, we have our inverses of each function. Again, anything of x, this is just a fancy way of saying y, and we're going to switch the x and y's around. So I get those switched, and now I solve for y. So again, we're working on isolating y. And then my last step is just to divide by the negative 5. And no, if you don't put the little negative 1, it doesn't mean you did it wrong. Okay? Or if some of you individually divided each part by negative 5, maybe you went through and you ended up with this for an answer. Okay? They're both fine. They're both absolutely fine. You've just got to, again, switch the x and the y, and then solve for y. You're like, well, wait a minute, 15 looks kind of weird. Okay, talk me into it. So there's my y, so I switch them. And you're like, well, y is down there, though. I'm dividing by y. What do I do? Well, if these were switched and it was y divided by 3, what would you do? You'd multiply both sides by 3. So we're going to multiply both sides by y. Like, that's kind of weird. Yes, it is. But I want to solve for y. So let's see. It's y times x right now. It's the opposite of timesing by x. Dividing. And we're set. So again, this wraps us up to this review. We're heading home towards the end here, so stick with it.